Okay, good morning. Internal energy of system. Internal energy is the total energy contained within a system due to microscopic motions and interactions of its particles, molecules, atoms, ions, or the energy associated with a system by virtue of its position or its molecular constitution in potential energy. It includes kinetic energy, that is translational, rotational, vibrational energy, kinetic energy, translational, rotational, vibrational energy, potential energy, intermolecular forces, bonding, intermolecular forces, bonding, potential energy, translational energy, vibrational energy, and rotational energy, kinetic energy. Molecules possess energy by virtue of motion, which is called kinetic energy. Components of internal energy, translational kinetic energy of molecules, rotational kinetic energy, vibrational energy, intermolecular potential energy, electronic energy in atoms, molecules. The sum of all possible kinds of energy associated with a system by virtue of its position or motion or both in what is called internal energy of intrinsic energy and denoted by E, or also we can denote by capital U. Some facts of internal energy can be summarized. Total energy, internal potential energy, and internal kinetic energy. Absolute value of internal energy cannot be measured, but change in internal energy can be measured. Internal energy is the function of temperature, pressure, and volume. We can denote E equal to F, T, P, and V. Hence, internal energy is a function of either P and V or T and P or P and T. Internal energy is the function of either pressure and volume or temperature and pressure or pressure and temperature. Mathematically, E equal to FPV, E equal to FTV, E equal to FTP. Internal energy state function, its value depends upon state variables, pressure, volume, temperature only. Its value does not depend upon part, but only depends on initial and final condition. If E1 be the internal energy of a chemical substance under one set of condition, and E2 be the internal energy due to change in condition. Then the change in internal energy is given by D equal to 0. Internal energy is the extensive property. Its value depends upon the quantity of matter present. A fixed quantity of chemical substance under a given set of conditions has fixed value of internal energy. The value of internal energy is different chemical substance. Sign of internal energy change delta E for chemical reaction delta E equal to E product minus E reactant. If a chemical reaction proceeds by decrease in internal energy, that is internal energy of product is lesser than that of the reactant, some amount of energy is lost to the surrounding and delta E becomes negative. That is delta E equal to EP minus ER, delta equal to minus, if negative, ER is greater than EP. If a chemical reaction proceeds by increasing internal energy, that is internal energy of product is greater than that of reactant, some amount of energy is gained to the system and delta E becomes positive. That is delta E equal to EP minus ER, delta E equal to positive if EP is greater than ER. Unit of internal energy can be expressed in different units. The SI units is joule or kilojoule, and calorie, that is 1 calorie equal to 4.184 joule. Experimental determination of internal energy delta E. The internal energy change during a chemical reaction can be determined by using Bohm calorimeter. In practice, enthalpy change of a chemical reaction is measured by using calorimeter. The process of determination of enthalpy change of a reaction is known as calorimetry. Calorimeter or calorimetry is related with the unit of the heat calorie. Different types of calorimeter may be used in different circumstances, but Bohm calorimeter is used to measure the heat of combustion. Bohm calorimeter was developed by Bartlett in 1881 to measure the heat of combustion of organic compounds. Principle. A calculated amount of a chemical substance is taken in a sealed combustion chamber made up of steel provided with internal coating with non-oxidizing matter or gold or platinum. The sealed combustion chamber is known as bomb. When the organic compound is burned by passing electric current, then the amount of heat energy released is measured. According to the first law of thermodynamics, dq equal to d plus pdv, since volume is constant, dv equal to 0, the expression becomes dqv equal to d. Since the reaction is carried out constant volume, no work is being done in the calorimeter. In such condition, the heat change of the reaction is equal to the internal energy change of the chemical substance. Combustion reactions are exothermic, so delta H has negative value. This is the figure, Bohm calorimeter. Compound is bond that is reacted with oxygen and produced the products and heat. Heat evolved is the heat of the combustion at constant volume. Heat evolved dQ equal to mass of the substance, specific heat capacity, and rising temperature. So dQ equal to D equal to ms delta T. Process of fixed mass of the chemical substance whose change in the internal energy is to be determined is placed in a crucible inside a steel bomb filled with oxygen at a pressure of 20 to 30 atmospheric pressure. The steel bomb is lowered into water bath kept in a insulated copper vessel. Okay, the vessel is provided with one stirrer and our thermometer. The whole part is insulated to ensure perfect insulation. The temperature of water bath is noted before combustion, that is T1. By passing electric current, the sample is ignited. After constant stirring, the final temperature T2 is noted when complete combustion takes place. The increase in temperature is found by relation delta T equal to T2 minus T1.